Are you ready to use those graphing calculators again? Okay, so lesson 4.3 is just doing a quadratic, finding a vertex, finding a max and min, finding whatever they ask you to find, using your graphing calculator now. So I want you to look at this problem, and then I'm actually going to jump to my other calculator on my computer. So most of the time you won't actually be looking at my screen up there. You'll be looking at my calculator up there, but it'll be good. Here's what it says. The table shows temperatures for a day in October in Sacramento, California. Okay, and they use military time here. Why do you suppose they use military time for a problem like this?
12 and 1.
Right, when you jump from 12 to 1, if you think about that on a graph, right? If we're gonna plot 12 and then 1, all of a sudden it's like, oh, we were moving this way. Oh, we gotta drop down to 1 and start all over again. Doesn't make a lot of sense. So they use military time so that as the time is increasing, your number is increasing, right? So just don't get thrown off by military time. That is the wrong notes again. I really want to teach you guys geometry today, apparently. Your phone does military time? All of your phones will if you want them to. You just have to choose it. Okay, so you have the time and you have the temperature. So it says graph the data on your calculator. You know how to do this. Do you remember how to do this? Let's jump to the calculator real quick and think through it. Okay, now it's been a little while. What's the very first thing you should do? You should clear it. Good job. Okay, so you're gonna go, are we up there? We're up there. Okay, first thing you should do is you should go to y equals, and notice this, I have this big funky ugly equation in there. We don't want that in there because that's gonna throw things off for you. So you're just gonna hit clear. Notice right here, see this box? See where it says plot 1? That should be a dark black box around your plot 1. If that is not there right now, you're gonna arrow up to it and hit enter, and then arrow back down and make sure that there is now a black box there. Does everyone have the black box? Yes. Awesome. Okay, what's the next thing you're gonna do?
Go to stat.
Stat. You guys are so smart. Okay, so once you're in stat, we want to edit our list. So you're gonna hit enter at 1 or hit the number 1. And then we wanna clear, not delete, right? We wanna clear our list. So you're gonna go up to L2, hit clear, and then hit enter. Okay, then go over to L1, arrow up, hit clear, and then enter. Okay, it's cold. Oh, I was really warm, so I turned the air on. Sorry. My room is like bipolar. It's either really hot or it's really cold. It doesn't have an in-between, I feel. Yeah, my house is always freezing. My husband sets, yeah. Anyway. Okay, so when you're entering these things, you don't need to enter these numbers as 800, okay? You can do 8, 10, 12, 14, 16, 18 is fine. So you're going to go in L1. You're going to put 8, enter, and then 10, enter, and then 12, enter, 14, enter, 16, enter, 18, enter. Okay, so that should be your L1. Now go to L2, and you're going to put in 52, enter, 64, enter, 72, enter, 78, enter, 81, enter, and 76, enter. What do you notice about your two lists right now? They're the same length. Make sure they are. If they're not, you missed something or you added something that wasn't supposed to be there. Also, take your time when you're putting these numbers in, because if you put in a 74 instead of a 76, your answer is different than everybody else's, right? So take your time putting your numbers in. Okay, the next thing you're going to do, we don't need to store this equation. We don't need a line in this. We just want the data points. this. We just want the basic curve. So you don't have to do any of the fancy that we did last time. All you have to do right now is hit what to graph it? Zoom 9, okay? So you're gonna go zoom up here in the middle, then hit 9, okay? And you'll see your data points. It's lovely, right? I'm gonna graph this on the board. So your points will look something like this. You don't need to wait for the line. Remember I always said wait for the line and then graph it once you have the line. We're not doing the line. We're just doing data points for this. So plot it right away is fine. 1, 2, 3, 4, 5. 1, 2, 3, 4. Perfect. So it should look something like that. Okay, but I do want to know your window. How do you find your window? You hit window. Yes, I know. It's fantastic. So your X minimum is 7. Your X max is 19. So that's here and here. Your Y minimum, you can just call that 47 is fine. If you want to call it 47.07, that's fine too. And then 86, I would call it. I'm just going to round it. Okay, so that's your general window that you're seeing for your graph. You don't have to round it. You may leave it exactly as it is. That's totally fine. Okay, so this down here, what are we talking about for our X values in this problem? Time, yeah. It's the time. This one is the temperature. Your Y values are your time. Y value is your temperature. X value is your time. And that's just in the chart that we started with. It says 8, 10, 12, 14, 16 time. The other one temperature. Okay, so this is our data. Then it says, what's the next thing? Label your X and Y scales. Letter B. What is the quadratic model for this equation? Okay, now this is where there's one new step, but it's very minor, and you're going to get it right away. You're going to go stat, and then we want our equation, okay? That's the quadratic model. So arrow over to calculate. And now here's where it's different. Any guesses what number you're going to push right now?
5.
Number 5. We've done linear regression. Now we're doing a quadratic. So the only difference in today is you hit 5 instead of 4. Is literally the only button you need to push differently, okay? So hit 5, and now you'll just enter, enter, enter. We're not storing the equation, so don't worry about that. Hit enter one more time so you can calculate it.
What if I did store the equation?
If you graphed it again, you would see a line through your parabola.
Okay.
But it doesn't matter. Okay, so now it says, what is the quadratic model for this data? I didn't write on there how many places to round. I'll tell you where to round on the quiz. I think I told you where to round on the quiz. I should maybe check that. You go stat, and then arrow over to calculate, and then just enter, 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 enter until you calculate the equation. Okay, so this is letter B, the quadratic model. This is your equation, and it looks like this. So we're going to round to 3 decimal places on this one. So y equals, this would be a negative, did my numbers come out right there? Yes. Negative 0.469 x squared, right? Because now we have an x squared in our setup. So our a value goes where the a is. Our b value, so plus 14.716 is where our x goes. And then minus our c value, 36.121. Okay, so when they ask you for the quadratic model, they're asking you for your equation. That's it. That's letter B. Any questions on that? Okay, part C, I'm just going to tell you right now, this letter C is a little bit tricky. The ones I give you on quizzes and tests are not this tricky, but I think this is kind of fun to have to think through how you could figure this out. So think with me here, how we would do this. Letter C, actually, I'm going to jump back because we don't need the calculator anymore. Let me jump back to my iPad. asks, are we up there? Yes. Letter C, use your model to predict the high temperature for the day. At what time does the high temperature occur? Okay, so first of all, think about this. We are going to predict the high temperature for the day. What variable is that? The high temperature for the day. That's your Y, okay? So we are going to find Y with that. Then it says, at what time does the high temperature occur? What is that? Your X, okay? So we are finding a vertex. We're looking for a point somewhere right around here, right? We're looking for the peak. We're looking for the vertex of our parabola. So find the vertex. Whenever it says the maximum, find the peak, whatever. God bless. We are going to find the vertex. And the way we do that is our negative b over 2a. So x equals negative b over 2a means a negative b right now is a negative 14.716 over 2. And then your a value is the negative 0.469. Okay, now again, please put parentheses around that or multiply the bottom two numbers first. But if you do not put these parentheses in, you will get the wrong answer. I promise. Okay, so put those in. When you plug that into your calculator, so negative 14.716 divided by parentheses 2, another parentheses, negative 0.469, and then you don't even have to finish your parentheses off, but you have to start them both. Hit enter. You get 15.689. Okay, now. Yeah, I'm using 3 for this. Here's what I want you to think about. This is where it's a little bit tricky. Hi, who do we got? Matthew.
Needs to leave right now.
You're leaving. So 15.689, we said that's our which variable? That's our x, right? We solved for x. Okay, so 15.689 is not 1568, because if we're thinking time, that would be saying what time? 368. Does 368 exist? No. This is a decimal. This is a, think of it like a fraction. You're good. Shh, that's for me.
It'd be like 340-ish.
Oh, you're so close. So 0.689, right? That's a fraction of an hour. So here's how you have to think of it. First of all, this is 3 something, right? 1,500 hours is 3 something. We need this fraction of an hour to figure out how many minutes later it is. So what you're going to do is you're going to take 0.689 and multiply it by what? 60, right? It's a fraction of an hour. So how many minutes? So multiply it by 60 minutes. So 0.689 times 60. This is the stuff I won't make you do later, I promise. Equals this. 41.34. Okay, so what we're saying is that 0.689 is about 41 minutes. So our time would be 3:41 p.m. Okay, so at what time does the high temperature occur? It occurs at about 3:41 p.m. Does that make sense? I know that's a little bit all over the place. I promise I won't do it to you on a quiz or a test, but it's just kind of fun to have to convert that. How do I find the high temperature at that time? Plug in 15.689, right? Don't plug in 341 because that's not how we're using it in the problem. We're using this in the problem. So you're going to plug in the 15.689, but you're going to treat that like 3:41 p.m. Okay? So you're going to do y equals, let's see, negative 0.469 times 15.689 squared plus 14.716 times 15.689 minus 36.121. And you're literally just going to plug that into your calculator exactly how you see it. And what do you get? Did you get 79.316? Did you plug it in? You should plug it in. Make sure that you're plugging things in correctly. So basically, here's what the question is. Predict the high temperature. At what time does that high temperature occur? So we would say it's about 79 degrees at 3:41 p.m. Good on that? Okay. The next one's easier because you don't even need to find as much, although it's a lot of numbers. So it's going to take a little while to plug these ones in, but you'll be good. Okay, so I'm going to jump back to my calculator. And we're going to plug that second chart in. What's the first thing you need to do? Make sure your y equals is clear. Now, if you didn't store your regression equation last time, there shouldn't be anything there. If you did store your regression equation, you need to clear it again. But these ones, because we're not storing, you don't actually have to clear every time. I would still check it just in case you happened to store something somewhere. So it should be clear. Then you're going to go stat and then enter for edit. Now clear your two lists. So up, clear, enter, left, up, clear, enter, empty lists. Does anyone want me to read you the numbers, or would you rather just read them on your own? Nobody wants me to read them. You want to put them in yourselves? Okay, put them in yourselves. Do you see a pattern on the left there, hopefully? Just counting by fives, right? Not so much on the right. All right, you got them all in? Okay, where do I go from here? Zoom 9. Hit zoom, and then the number 9, and you should be seeing this. 1, 2, 3, 4. 1, 2, 3, 4. Then we drop down a little bit, back up. My best work, but you get the idea. So you have this parabola-ish shape, right? There's some variance in it, but it's still got that basic arch. What do you need to do next? The window. Hit window, right? We want to know what that window is. So your X min is 9. Your X max is 81. Your Y min, again, I don't care if you round that to the nearest whole number, but 20.923 if you don't. And then the Y max, 31.777. So you have those, okay? Label what you're working with. So on the bottom, what are we talking about? What's your X? That's the speed. What's the Y? The mileage. Never even read the question to you, huh? Comparing speed X in miles per hour with mileage Y in miles per gallon of an automobile is what we're doing. So then it says, what is the quadratic model? So this is A. A is done. Part B, what's the quadratic model? What do you do? Not edit. Calc. Arrow over to calc. And then number 5, quad reg. And now just enter until you calculate it. So your equation should be y equals negative 0.008 x squared plus 0.746 x plus 13.469. Okay, if we're doing 3 decimal places again. Okay, now read part C. It says use your model to predict the speed at which the mileage is the greatest. What are you finding? The vertex, but do you need the whole vertex? You only need X, right? All they asked you for is predict the speed where the mileage is the greatest. Well, you could find what greatest mileage there is, but it doesn't ask you what is that greatest mileage, right? So all you need to find here is your X. So you're gonna plug in, let's jump to this. God bless you. Okay, so really all you're doing here is X equals a negative B. So it's going to be a negative 0.746 over 2 times your A value, negative 0.008. Please don't forget the parentheses. So plug that into your calculator with those blue parentheses, and you should get, anyone got it?
46.625.
That's the one, 46.625. What is that? 46.625 what? Miles per hour, right? Speed was in miles per hour, it said up here. The speed X in miles per hour. If you don't label that miles per hour, I will take a half a point off. Label it. Good? Yes. You have to do this one and you have to do this one. Well, that's not true. You have to do the first one. You could make this the time symbol if you prefer that second one, because we're just multiplying those things, but you have to start a parenthesis after your division symbol here. Negative 0.008. Yep. Yeah, you don't even have to end the parentheses. Like, you don't need either one of these. The calculator assumes the end of them. You just have to start them. Yeah. Yeah, where's your phone? Leave that somewhere nearby. Any questions? So if I wanted to know at what your miles per gallon were, what would I do right now? Plug it in. Plug in that 46.625 into your original equation, and you would get your miles per gallon for that. That's it. Good? Okay.